Okay, so hello everyone and welcome to Mclean 360. This question is actually about planetary gears, where we've got an epicyclic. So it's like think about the sun, which is stationary, and then we have a planet moving around in an orbit. It's essentially that's how this sort of gear arrangement looks like. So sometimes we call them the planetary gears. Okay, so let's read the question together and solve it. Over here, we've got a gear B, which is actually having 120 teeth externally. Okay, so if you look at the external side, okay, the number of teeth at the external side is actually 120, and that is meshing A. Okay, but then the internal side, which is 100, is actually meshing E. Okay, sorry, it's meshing so E is actually arm. Okay, E is like an arm. Yeah, and then D to D, this is D. So essentially C and C here are actually idlers. Okay, or idle gears. Okay, so they don't really do anything, but they are just in position so that they can hold the arm C. Okay, but then they are actually idlers. So the most important thing to talk about is the interaction between A and B, and then between B and then D, because you know E is actually connected. That's the arm is connected to D, so there is going to be some form of relative motion. Right, let's start from B. So writing the gear ratio is basically um so gear ratio is always driving speed, so driving speed divided by driven speed. Okay, but in terms of number of teeth, it's the same as what? Number of teeth. So number of teeth on driven, all divided by the number of teeth on the driving. Okay, so having known that, in terms of B and A, we can say that the speed of B and then A, in terms of the external arrangement, then we can say that the number of teeth externally, okay, so actually it's going to be TA over TB. So because you know A is moving, so this is driver A. So if A revolves at 100 rpm counterclockwise, so A is moving in this direction counterclockwise. Okay, and then when A moves in counterclockwise, he's also saying that D is also moving counterclockwise. Okay, so essentially that's basically what's happening. Since since A is moving counterclockwise, it's going to force B to move in the opposite direction. Okay, and basically it's like saying B will move clockwise. But what is that value? Let's calculate that value together. That value is going to be, so NB is going to be minus, because of the clockwise, NA multiplied by TA divided by TB. So NB is essentially minus 100 multiplied by TA, which is 20, and then you multiply divide by TB. So TB is externally is 120. Okay, that's basically NB. What's the speed you are getting? So the speed is going to be 100 multiplied by 20 divided by 120, and that's 16.67. So minus 16.67 rpm. So the negative sign is just nothing but telling you that the direction is going to be clockwise. Okay, so that's the direction of the B. Now if you look at so someone will ask, why not include C? So as I said, these two gears here, C here and then C here, they are actually idlers or idle gears. They don't do anything. Okay, they don't contribute to anything. They are just helping us to mesh E and B. Okay, but they are not really doing anything. They are just holding the arm for us. Okay, right. Now the next thing to do after this is to essentially look at DBE. So this the system DBE is nothing but we are going to write D over B. Okay, so D over B was supposed to be the number of teeth on B, or okay, let me just say the number of teeth on B, the number of teeth on D. However, since D and B, since D and B are connected together by, so if you look at the direction, if you look at gear B, and then if you look at gear D, so this is gear B and this is gear D, they are connected by an arm. Okay, and this arm here is actually going to cause some sort of relative motion. Okay, so to account for the relative motion, what we normally do is, so we subtract the relative motion from both sides. That's all. So whenever you have a planetary gear, what happens is that because of the whenever you have an arm, okay, so two gears and you have an arm which is relative to the two, then we essentially account for the arm. So the arm is actually this E. The E is an arm. Okay, right. So with this we can go ahead and solve. But then what do we have? So we know that internally, so because this is touching internally is 100. The number of teeth on B internally is 100. Okay, and then so the number of teeth on D, so D has 60. Okay, so we have 60 and then 100. Okay, so this one, and then what do we know? We also know that okay, so that's all what we know. Okay, that's all what we know. So let's try and express something here. So we can say that this is 100 divided by D. So D is 60. Okay, but then we realize that looking at the direction, if we move this in clock, so A move counterclockwise, B move clockwise, it will force D to move in the sort of counterclockwise direction. But because of the arrangement, okay, because of the arrangement, finally, if you are looking at the, okay, so if you are looking at the arrangement here, what happens is that finally, because of the arm, we expect that, so actually what happens is that this is actually an internal gear. Okay, this is like a sun. Okay, so E is like the sun. Okay, and then the planet moving around the sun. So because of that, it's actually going to cause this to be negative. Okay, so we actually have negative. So yeah, we have negative right here. Okay, and 100 divided by 60 is going to be, so 100 divided by 60 minus 5 on 3. Okay, right. So we have minus 5 on 3. Okay, so our task is to actually solve for, so we have, okay, let me just write everything. So we have ND minus NE is going to be minus 5 on 3. And this is going to multiply NB minus what? NE. Okay, so this is what we have. But is there anything that we can do about this? So the answer is yes. Why? Because we have the values which we need. Okay, we have the values which we need. So let's see if we can put the values inside. First of all, we can say that okay, so we have our value for NB here. We got NB to be minus 16.67. And then I think we have another value here for our, okay, so we also have ND here. Good. So ND is 27. We have NB here. So let's put the values inside. So 27 minus NE should be equal to minus 5 on 3, which is multiplying NB, which is minus 16.67. You know, this minus will become plus. So plus 5 on 3 NE. All right. So at this juncture, we are solving for NE. So we just have to, okay. So it's going to be NE into bracket 1 plus 5 on 3. Okay, bringing NE to this side. So it's like bringing NE to the side. And then we can send, so 27. This is already going to be positive, so it will come here, become negative. So 5 on 3, 16.67. And whatever we have for NE will be 27 minus 5 on 3, 16.67, all divided by 1 plus 5 on 3. And that's basically the speed of the arm, E. Okay, and the question was saying we should find the speed of arm E. So that's the answer. Let's punch it in and then we are done. All right, so if you pick your calculator, what is it? It's going to be, okay, so 27 minus 5 on 3 into 16.67 divided by 1 plus 5 on 3. That gives us minus 0.29. So minus 0.29 in terms of RPM. So that's basically the kind of rotation of the arm E. The minus sign is just telling us that it is actually rotating in the clockwise direction. So this problem has been solved. Thank you.